Imagine a vessel that can disappear beneath the waves, exploring the ocean's depths almost silently, a true ghost of the sea. What incredible technology allows these amazing ships to operate in such a unique way, making them nearly impossible to detect? Submarines primarily use electric propulsion because it is the only way for them to operate silently and effectively underwater for extended periods. This method allows them to maintain deep submergence and achieve the stealth that is absolutely critical for their military and intelligence-gathering missions. Without electric motors, the very concept of a long-range, undetected underwater vessel would be impossible. The core reason for this critical design choice lies in the fundamental difference between operating on the surface and operating deep beneath the waves. Traditional combustion engines, like the diesel engines found in many surface ships, requiring a constant and ample supply of air to combust fuel. They also produce significant exhaust gases that must be vented. Using such an engine underwater would mean the submarine would either have to constantly surface, breaking its stealth, or use a snorkel mast very close to the surface. Both options dramatically increase the risk of detection and severely limit operational depth and endurance. Electric motors, on the other hand, run purely on stored electrical energy. They generate no exhaust, requiring no air for operation, and most importantly, they operate with remarkable quietness. This near-silent operation is the cornerstone of a submarine's stealth, allowing it to approach targets or conduct surveillance without being heard by sophisticated underwater listening devices. In practice, submarines employ large, powerful electric motors to turn their propellers, pushing the massive vessel through the water. The electricity for these motors is generated and supplied in different ways depending on the submarine's type. Conventional diesel-electric submarines, often called SSKs, use diesel generators to create electricity when they are surfaced or at snorkel depth. This electricity then charges large banks of batteries. When submerged, the submarine switches to battery power, running its electric motors silently. Nuclear-powered submarines, known as SSNS or SSBNS, utilize a nuclear reactor to generate immense heat. This heat creates steam, which then drives turbines to generate a continuous supply of electricity. This constant power output allows nuclear submarines to power their main propulsion motors and recharge their batteries, enabling them to stay submerged for literally years at a time without ever needing to refuel or surface for air. One fascinating engineering detail for non-nuclear submarines is the air-independent propulsion system, often called AIP. This advanced technology allows some diesel-electric submarines to generate electricity even while fully submerged, without needing to snorkel for air. Systems like fuel cells or Stirling engines can extend a submarine's underwater endurance significantly, moving beyond just battery power. For nuclear submarines, the ability to operate for decades without refueling their reactors is a true game changer, offering unparalleled global reach and persistence beneath the waves. This continuous, silent power supply fundamentally redefines naval capabilities. Ultimately, the choice of electric propulsion is what defines the unique operational capability of a submarine. It is the indispensable technology enabling their ability to operate unseen beneath the waves, maintaining their stealthy profile for extended missions. This silent power ensures they can perform their vital roles in national defense, from gathering critical intelligence to projecting strategic power, all while remaining an invisible, yet extraordinarily potent, force in the world's oceans.